Hello, everybody, and welcome. I'm Jonna Till Johnson, and I'm here with a couple of super smart guys to talk to you about the ramifications of transparent cloud and network security. I'm going to go ahead and ask the guys to introduce themselves. So Aidan Walden from Fortinet, would you like to go ahead and introduce yourself, Aidan?
Yeah, thanks. I'm Aidan Walden. I'm the Director for Public Cloud Engineering and Architecture at Fortinet.
Thank you. And we also have Samir Kumar Vasantapuram from AWS. Samir?
Thanks, Jonah and Aidan. My name is Samir, and I am a Partner Solutions Architect at AWS.
Great. Well, glad to have you, and let's jump right in. Samir, I know when we were preparing this webinar, one of the things you wanted to talk about a little bit was what are some of the design considerations that enterprise technologists should have when it comes to cloud and network security?
Yeah, absolutely. So when I talk to customers, some of the things that we could, typically look at when we're designing for network security in the cloud are 6 different aspects that you'd see in the slide here. We start off with identifying the directionality of the traffic that is going to the application. So we have applications that might be receiving traffic inbound from the internet, outbound to the internet, or these might be applications the customer has between their on-premises and the cloud, and they want them to talk to each other. And what that really dictates is how you build your security policies. Because an application that is receiving traffic from the internet is going to have a completely different threat model compared to one that's working between on-premise and the cloud. Now, the other aspect of things is as customers have separated their environments on AWS as a best practice into development, test, and production, not all of them will require the same sort of availability and scaling depending on how much traffic that runs through it. So you also want to consider how your availability for each of these different environments is structured, which leads us to the 4th point, which is as you think about availability and the directionality of traffic, you might also want to consider how much bandwidth you're pushing through this and how do you scale and load balance that traffic across your inspection capabilities that you want to provide for your different applications. With that said, customers now have the ability to split up their applications into multiple VPCs or virtual private clouds, as we call them, which are, think of it as mini data centers in the cloud that you can deploy your applications into. And customers typically have these VPCs as boundaries for their applications themselves. So how do you interconnect applications? How many VPCs are present? And how do you actually make them talk? Is it decentralized in a way that you're routing everything to the internet? Or is it coming together in a centralized place for inspection capabilities to be performed? And finally, what's important is to identify the applications and protocols you use themselves. Because a web application, again, has a completely separate set of security policies and inspection capabilities that need to be done on them, as opposed to a non-standard protocol-based application, which might have a completely separate set of threat models again.
So Samir, I love that you have a very methodical approach to the key considerations. And I know you're going to talk about scalability and availability in a second. But before you do that, I want to ask you just, when you talk about the directionality of traffic, the question that arises to me is, how would an engineer necessarily know the directionality of traffic of an application that they're just putting on the cloud?
Yeah, absolutely. One of the things that you definitely want to work with as a security or a network security engineer is to work with your application teams to identify who your users are, where do they exist, and where does that traffic come from? So if it's an application that's public facing, then you're likely going to have a set of users coming from the internet. And what's also important to understand is which set of customers you're using, whether that's somebody from the EU versus somebody from North America, because that has implications on how you write security policies as well.
Mm-hmm.
Oh, that's that. Yeah, that is actually fantastic insight because basically you can't simply accept the application as being tossed over the transom. You have to sit down with the developers and ask some key questions. And Aiden, I
Absolutely.
saw you nodding. Did you have anything you wanted to add to that?
Oh yeah, these are fantastic points. And when we within our practice consider or work with a customer to deploy these types of environments, these are the exact points we're thinking about. And when you talk about directionality of traffic, it made me think of also the regionality, right? So your infrastructure is probably going to be deployed over a number of geographies if it's scaled potentially within a continent or globally. And so understanding the implications for sending traffic from region to region. There are privacy laws in place. There are costs associated with that, and that's actually a part of security concern as well. And one of the things, Samir, I would throw this back to you to consider is that this is an evergreen life cycle, right? So we're looking at all of these different touch points or considerations when building out the infrastructure, but it's very much like the day zero, day one, day two type model where it comes back around and you constantly want to look for opportunities to improve because AWS is going to continue to push the paradigm of what network security is, what the infrastructure can do, and you want to keep up with those changes.
That is an excellent observation. So this isn't just, not only is this not over the transom, take the app and engineer for it, but it's also not a once and done. You want to revisit the assumptions that you're making as you get better and better data.
Exactly.
Yeah. Spot on.
And Samir, I know one of the key areas that you really wanted to highlight was this whole discussion about scaling and availability. So what are some of the things that people should be thinking about when they're, thinking about scaling and availability requirements?
Yeah, and to Aiden's point, when we think about scaling and availability and also take into those design considerations, one of the things that we always let customers know is consider this as an evolving sort of architecture. Don't plan for this as something that exists, over a 10-year period. We do move quickly, and you probably want to adapt as the application lifecycle changes the architecture. So given that sort of framework, the scaling and availability of your network security infrastructure is going to really depend on some of those earlier considerations, and it will evolve as the application evolves as well. In general, we have multiple ways of approaching scaling and availability, and there are constructs that are available through AWS networking services, which enable a customer to have both a highly scalable network security infrastructure and make it as much as available as the customer decides. So with that said, the first few things that we start off is by identifying whether the customer is working with more of a dev test sort of an approach where their infrastructure doesn't need they don't need the amount of scaling and bandwidth that the environment dictates. So you work with things like interface shifting and route shifting, which uses AWS API calls to enable failures to be handled by moving the traffic over to a standby set of infrastructure that the customer can deploy. Now, with that said, as you start scaling up both your the amount of traffic you're sending as well as your availability requirements, the way you need to architect these change as well. So with things like elastic load balancer sandwiches and transit VPCs, what we created was a way to have a cluster of devices being able to handle the traffic and then decide based on different mechanisms how to either offload traffic from an instance that isn't available anymore, or use sort of routing-based mechanisms to fail over traffic as well. Now, as customers became more and more complex in their architectures and had multiple applications talk to each other, they had two requirements. One is, I want the same set of infrastructure to be used for inspecting all of these different applications. But, oh, by the way, I also wanted to scale based on the amount of traffic I'm sending. So with things like AWS Transit Gateway, which enables connecting multiple VPCs with each other, and also things like on-premise devices and site-to-site VPNs, Customers now have the ability to centralize all of their traffic to then push through an inspection service and apply those different security policies we talked about. The final bit of it is, as you sort of think about this mix of traffic coming in, one of the things you want to handle is, how do I distinguish them without changing a lot of the metadata that exists in the packets themselves? And so with AWS Gateway Load Balancer, which is a new type of load balancer that we launched last year at reInvent, we now have the ability to give security appliances the visibility that they require into the packet while still enabling them to scale across a broad amount of bandwidth that they can make available to their customers.
So I know you're going to be talking a lot about the GLB in upcoming slides, but before we jump into that, I wanted to ask a question on the availability front, because I know customers often are coming at this from a perspective where they have a very defined business continuance and disaster recovery kind of model. And one of the things the cloud lets you do is make that a lot more real time. So everything is always on, because you've actually built the redundancy into the cloud infrastructure. And I know that's not specifically the topic of this webinar, but any thoughts on how customers should need to rethink their availability policies given in light of new technology?
Well, absolutely. It's a very valid point. And it comes back to how the cloud itself is extremely different from sort of how your on-premises infrastructure is built. The cloud gives you APIs that you use to handle failures, as opposed to having different mechanisms at the network layer to handle some of these failures. So as you think about building availability, you want to understand how you're going to orchestrate the cloud infrastructure to make your availability work for you, as opposed to using the network fabric itself or the hardware that you use to orchestrate for availability. So the major change that customers need to think about is orchestrating via APIs and handling it via the cloud, versus relying on sort of the appliance itself to handle failures for you.
That is an excellent point, and one that I may come back to. But before I do that, Aidan, any comments on scaling and availability?
I think, and I can get into this in the next piece, is the evolution of the network really allows for scaling in a much easier way than it used to. And I think that's just part of the whole theme of network modernization that we're talking about here with AWS. Yeah.
Well, so with that, let's talk a little bit more about the whole, gateway load balancer and its ability to ensure consistent performance with consistent security, which is always the challenge. Usually it's an either or, right? You can have consistent security, but not consistent performance, or vice versa. So, since that's a key piece of the new technology, Samir, you want to talk a little bit about it?
Absolutely. So gateway load balancer, like I said earlier, is a new type of load balancer that allows our partners and other security appliances to scale alongside the infrastructure that we provide to enable security to scale with the traffic that is being delivered to it. Now, the other aspect of the gateway load balancer comes back to the requirement from all of the security teams that we worked with, to identify specifically where is this traffic originating from, without obfuscating sort of things like IP addresses and other metadata that might be present within the packet, that enables them to make that decision on whether this particular set of application traffic is malicious or not. So gateway load balancer actually provides two constructs that enable customers to do this inspection of traffic in a transparent manner. We have something called the gateway load balancer endpoint, which acts as the entry point for all traffic to be inspected across a customer's AWS environment. Whether that's multiple VPCs or across AWS accounts, it really doesn't matter. We're able to deploy the endpoints into multiple different environments on AWS and have traffic come into the load balancer which then sort of encapsulates all of this in a certain set of, in a protocol that we call Geneve, and then delivers it to a particular appliance that sits behind it, which is, it could be a firewall, it could be a WAF, it could be an IDS, IPS device, which then makes the decision for the customer and then tells us whether the traffic needs to be routed back or not. So the requirement for scaling and bandwidth is addressed through sort of that mechanism. And with this encapsulation bit, you now have the ability to deliver traffic transparently to the security fleet that sits behind it.
That's great, Samir. Is there anything you'd like to go ahead and add, Aidan?
No, but I think what I want to do is take us back a little bit in the history of networking in AWS, if that's okay.
Absolutely. Take it away.
All right. So, if you've been around AWS for a long time, I think I came in probably around the second phase of networking. Samir, maybe, I think you've got a lot more experience in the Wayback Machine, but when it all started, it was really about VPC networking, right? Everything was local routed. And then, came the concept of transitive networking. Some, really creative vendor partners of AWS created the VPN transitive VPC model. You could do VPC peering, and that was effective. But, as we went forward, new models were needed to further segment because, in the data center, we had massive internal segmentation, and we had to translate that into cloud. And I think AWS served us all really well with the transit gateway. But the transit gateway also had its share of complexities. Really, one, establishing the entire environment, building all your route tables, and inserting services. And so now we find ourselves into this, what I call the fourth generation of cloud networking on AWS, which really is the ability to, for the first time, to insert transparently services without worrying about readdressing IP schemes, worrying about natting across the environment. And so it really makes life so much easier for the consumer. And so if we want to move forward, let's talk a little bit more about what we've got in detail here. And so I've got a pictorial here that I think is just illustrative of what we can do in a typical model for inserting security. If you look, well, two things. There are really two high-level requirements from a network security perspective. In this picture at the top, we call out north-south inspection. So that's ingress and egress from the environment, from the AWS environment. There's also the east-west use case. That's that internal segmentation capability, more or less. But let's just talk about north-south right now. So when we're talking about gateway load balancer and inserting security services, the idea is that we want to make sure all traffic gets inspected. And if you're a line of business owner who happens to own a VPC enclave, maybe you're just responsible for that, it's really easy to turn on security. You're given a gateway load balancer endpoint that you can point your traffic to within your subnets, and then away you go. That's your only real responsibility. So that's the left side of the screen. On the right side of the screen, it doesn't really get too much more complex. For the person managing the security enclave, for the DMZ, whatever you want to call this, inserting security is simply attaching, in our case, FortiGates or any inspection service to gateway load balancer ENIs. And these ENIs really drive traffic in a stateful way to the security appliance and allow that traffic to be inspected without the security appliance having to worry about source and destination IP addressing. They're just getting the traffic, they're inspecting it, and they're sending it right back to the gateway load balancer ENI from which it came. And so that really makes things massively simple, especially when you talk about that scaling problem or consideration we talked about earlier, right? So now I can scale this out really infinitely, depending on the needs of my business. Now, think about this from another perspective, right, Samir? I know you deal a lot with managed providers, as I do. If you're a managed provider or you're a customer who wants to use managed services, this is really a panacea, because now I can take, without having to modify my environment really to any large extent, I can take on those managed services, or I can implement managed services, and the provider is just worried about that security enclave, and then I can keep my account very distinct from that, right? Just my traffic, my route tables are updated to point to the security service. So it makes it very, very easy.
Well, and I like that definition of transparency. In a sense, I boiled it down in my head to saying you're decoupling your security from your network path, which is exactly the main point. But Samir, I do want to point something out to you before I ask if you have anything to add. Aiden just said earlier, you have a lot more experience with in the Wayback Machine than I do, which is a geek's way of calling you old. So I just want to make sure you caught that. But anything to add to the North-South discussion before we jump on the East-West discussion?
No, I think Aiden made a very good point in that it actually separates the administrative domains from the application owner to the security owner. And the security owner understands that they're going to receive traffic from an application and they have to identify and report on it. Whereas the application owner just says, you know what, this is fantastic because I don't have to do any complex setup of the environment. I just route traffic to it. So it's an absolute game changer from my perspective. Of course, I'm biased, but I feel like it's a great use case.
I agree. One of the things I will point out to the technical audience is the zonal considerations of the gateway load balancer. You can see on the right side that we fully mesh the Geneve tunnels across the appliance fleet to make sure that traffic is survivable across those AZs.
Yeah, which actually plays back into the availability that we talked about. So let's talk East-West. Aiden, take it away.
Yeah. This is where, if you're an existing transit gateway customer, this makes it really easy to really modify and keep up with those changes, right? We can simply, again, insert gateway load balancer endpoints into that environment. We don't have to throw away the transit gateway model. But really, we're driving the east-west segmentation. So if you take away the internet gateway from the prior picture, it's very similar, right? So traffic is routed from the VPC to the transit gateway as it is today, before gateway load balancer. Once the transit gateway picks it up, really, that's where that transit gateway endpoint is forwarding it to the gateway load balancer endpoint, which is then forwarding it on to the fleet of, in our case, FortiGates or whatever your security appliance may be. So still very, very simple to manage the routing, right? Very simple route table updates. And if you pause this video and take a look at this screen here, you can see how all these route tables are set up in very simple terms. But again, I think Samir said it best, where you're decoupling the administrative piece, the security component from the rest of the AWS infrastructure. And really, I think this really fits with the current motion that we're seeing, where IT owners are now looking to adopt cloud in a smart way with more mature constructs that they're used to, right? So early on, again, in that Wayback Machine, it was more of an app developer use case. Now security is being considered, I hope is being considered from the traditional IT buyer. And this really makes it life easier for them.
Yeah, and I think that abstraction of roles, along with the decoupling of network and security, is really kind of the big takeaway, at least for me, from all of this. Samir, do you have anything to add?
Yeah, a quick pointer also for the more slightly technical audience as well is given that transit gateway has this concept of route domains, you can even separate and identify which set of traffic goes through the inspection fleet. So you can potentially centralize all of the traffic using transit gateway, but then choose which traffic goes through the fleet that we have to inspect it, versus always having to send it via the VPC, where it always was deployed in the app-centric model.
Which again plays to one of your favorite theme points, which is scalability.
Yep.
So you guys have presented a lot that is both sort of interesting architecturally and interesting at a detailed level. What I'd like to do before we jump to a few questions is kind of sum this up so that somebody that's been following this webinar with us can walk away with some actionable takeaways. And Samir, take maybe a minute and give us maybe 1 to 3 actionable takeaways that network engineers, security professionals, cloud practitioners should take away from this and do differently after having watched this and listened to this than they might have been doing before?
Yeah, so collaborate with your application team, and that will help you with the design considerations that we talked about. It helps you construct a framework to decide on your architecture. So work off of the design considerations that act as the framework. And the second thing that I would say is always plan for this to be changing. We are going to have new things come out. And as application requirements change, you want to be flexible enough and plan for this particular set of architectures that you might deploy today to be very different in 24 to 36 months.
Okay, so basically, number one, collaborate with that application team. So work interactively with them. And number two, expect change. So revisit those design principles on an ongoing basis, as Aiden said at the time, and expecting changes in the technology to go along with it.
Absolutely.
Aiden, what about you? What are 1 to 2 things that people should take away and do differently?
One of the points I wanted to make is something that everybody should know. When I talk to customers and partners, they're oftentimes confused and challenged with, do I use first-party services or third-party services? Do I use the native, when I say first party, the native services of AWS versus an ISV partner solution like Fortinet? And really what Gateway Load Balancer provides is a way to bring those closer together. We're partnered with AWS on a number of fronts. Just to put in a plug here, with some first party services that you can consume directly from AWS. But when we provide services like this, the Gateway Load Balancer really gives you, the consumer, the ability to have the best of both worlds. So you're not compromising between, do I want cloud native or do I want a certain level of security inspection to meet some requirement? You don't have to compromise. So just know that, I would say. The second thing is tangential to what Samir, you said, is build security in from the beginning. I can't tell you how many times that I've worked with customers where the security team is brought in later, or security was considered after a fact because a compliance requirement had to be met. And then we have a redesign, and then that slows the entire project down. Consider security at the beginning of your design, and consider and build security in as evergreen process, so you can keep up with the changes that will inevitably come in your AWS capabilities.
So I guess I'm not sure I can pithily sum up your first point. Maybe you can help me here a little bit. But the first point seems to be aware of the options you have, whether it's first party or third party, and avail yourself of the right ones based on your requirements. Is that kind of a fair way to put it?
Yeah, I think it's just an awareness of that. These newer services allow you to have the best of both capabilities.
So yeah, be aware that you have choice, I guess. And the
Right.
second one is build in security for the design from the get-go. So kind of summing this all up into a set of things that the audience can take away. Plan to collaborate with your application developers, even if you are a network engineer, because you will need that information to develop the design criteria, and expect that those design criteria to change as technology changes and as your requirements change. Be aware that you have the option of kind of mix and match third-party, first-party services, and build security in from the beginning, from the get-go. So that's kind of a lot to wrap up, but hopefully folks have something useful to take away. And guys, you lived up to your billing as super smart guys. So now I'll challenge you with a couple of questions that we've gotten. The first one is, how do you guys see the transparent cloud network security from a sort of a broader cloud modernization strategy? And Samir, I'll start with you, and then Aiden, if you can chime in.
Yeah, I think one of the things that we hear from customers that we work with is we want to be able to identify if, all of the applications that exist within our environment, and correlate the traffic with the specific either metadata or resources that we have within AWS that can tie in sort of the information that, let's say, a SOC engineer might require to say that this particular application was the cause of this particular set of events that triggered a workflow for remediation. So transparent inspection enables you to simplify the identification of the application that might be causing potential vulnerabilities or even threats into your environment. And so that's one of the things that you definitely want to take into account as you move into this new way of doing things.
Yeah.
Okay. And Aiden, any thoughts? I know you're raring to go.
Well, I think that these new models really help the organization and maybe align better to organizational structure. You have IT teams, you have security practitioners, you have line of business owners, app developers. They can focus on what they do best, and they can bring those components together in an overall design. And so I think that's really the paradigm shift here. And if you're an organization that would prefer to lower your own level of effort and look to partner with a managed provider, that's also very easy too, because service insertion, as I mentioned earlier, is so much easier. And I'll just leave it at that.
Yeah, and my takeaway from this, and I think this question really emphasizes that, is that you can put the organizational boundaries where they make sense organizationally, not where they're forced to be by the technology, which was the old way of doing things. And I think, to me, that's actually incredibly powerful, because now you don't have to have security engineers worrying about routing tables. They can be worrying about implementing policies, which is exactly what they should be doing.
You said it much better than me.
No, it's from listening to you guys. So kind of last but not least, what about, do you have any great stories about how all this cool technology translates to interesting business outcomes? And Aiden, any thoughts top of mind, any client stories that you have?
So you put me on the spot here. I think, yes, it's really about, everything you do in clouds comes down to agility. And so for our clients, it's about migrating and evolving their cloud service offerings faster to deliver to their customers. And without calling a customer name out, the general feedback is that this allows them to just move so much more quickly toward going to market, getting services implemented. And so everything tends from agility and the ability to move quickly, and do that with less errors.
Yeah, well, that's the thing. You want to be able to move quickly, but you don't want to inject security vulnerabilities, and you don't want to make mistakes. And I think that's key, is that you kind of can have the trifecta. Samir, go ahead. Sorry.
I was just going to add to that. We're talking about network services on AWS and security services. Look for to use other constructs like Service Manager or stack sets, things that make deploying the infrastructure very simple. We at Fortinet have a number of solution sets that will help you do that, but definitely, start looking at those other constructs to help you get your infrastructure deployed in the easiest way.
Yeah, now that the capability is there, automate. You can move to the next level of automating. Yes. Samir, any good use cases or things you've seen work well with customers?
Yeah, so to Aiden's point, agility for sure, but I'll talk about it from the context of working with partners hand in hand to build some of this stuff. And we take feedback from our partners very seriously, because our customers like to have the choice of using multiple different services, whether it's from us or from somebody else. So with that said, all of this is constructed based on both customer feedback and, more importantly, partner feedback as well. And so we build based off of these set of requirements that we hear, and hopefully customers then get to enjoy the ability to scale and stay secure while moving fast.
And I think you just summed it up perfectly. Thank you both for your time today, and hopefully the folks that have been watching this have a nice portfolio of actions they can be taking to take advantage of all of this. Thank you very much.
Thank you.
Thank you.